Okay. Okay, so we can just start off with some like basic questions. So,
Okay.
where did you go to college for your undergrad, and what was your major?
University of Texas at Austin in chemical engineering.
Okay, cool. So, probably taking a lot of the same classes that we are now.
I think y'all are taking even harder classes than me, though, from what I know.
Yeah. Okay. What made you choose chemical engineering?
Well, I always was interested in science, and particularly chemistry. I had kind of a little chemistry lab in my house that I did some stuff with that I was probably shouldn't have, but I did. But I was very interested in that, and my father was an electrical engineer, so I kind of was interested in the applied sciences. So I decided to apply in chemical engineering, and that's what helped me get that first
That's cool.
make that first choice.
Yeah, I know it was kind of interesting when I heard that you were an engineer and then became a criminologist. So, what kind of made you decide to follow that career path instead of going into industry or doing research?
Well, I had some interest in medicine in high school too. We had some family friends that were physicians, and I had thought about that, but hadn't decided. So I just went in chemical engineering, and then a good friend of mine was doing pre-med, and as we started talking, I had seen some of the stuff he was doing, and I kind of decided that I just wanted to go into medicine. So, and luckily with engineering, a lot of the prerequisites were the same. A lot of the science background was there, so it just switching to taking a few biology classes, I could get all the prereqs in, and I went ahead and did it.
That's cool. So, what medical school did you go to?
UT Southwestern in Dallas.
Okay. So, as a pulmonologist now, what does a regular work day look like for you?
I don't know if we have regular work days. No. Well, we usually are up very early. They're probably in the hospital by 6 or 6:30. And we do a lot of work in the intensive care units. And usually we're in the hospital till roughly noon or so. And we have an outpatient practice too, so in the afternoon we're in the office. So most days are like mornings in the hospital, afternoons in the office. Then we also have, since our group has to cover the hospitals 24/7 for the patients, one of our group is always on call at night, and we also have to take rotations in doing the weekend call.
Okay, so busy.
It's busy.
Super busy. Did you have any like specific experiences that helped you choose pulmonology as your like specific?
Nothing specifically, but when you go through med school and training, you get interested in certain things, and I really was very interested in pulmonary physiology, the gas exchange properties of the lung and airflow and things like that. And you also get exposure to the intensive care unit, as where you're dealing with a lot of physiology. I was really interested in that. And it really wasn't until I'd actually gone through med school and also been a resident for 2 years that I decided on that. So it was kind of later down the road I decided to do pulmonary, because the training pathway to do that, you do your medical school, which is 4 years, you do an internal medicine residency, which is 3 years, and then you do an additional 3 years in pulmonary training called a fellowship. And it's in your second year of your residency that you really have to decide which branch you want to go into.
Okay. So you just kind of decided while you were in medical school instead of before?
Yeah. The decision to be a pulmonologist was much later. In fact, it wasn't until I had gone through med school and was actually doing a residency in general internal medicine that I decided to do pulmonary.
Okay, that's very exciting. So now I kind of want to ask a few questions about biology specifically, since that's the course that we're kind of talking about. So, what aspect of biology do you enjoy, or how has biology like itself influenced your profession, your career choice, anything like that?
Well, I think biology is obviously intrinsic to everything we do, and I can't say there's one thing that influenced me, but I guess it's just really been exciting to see the changes that have happened with biological research and how it's changed what we can do. The new therapeutic alternatives, different drugs, really the technology in biomedical engineering. from things like pacemakers to life support systems. All of that is really neat. There's not one aspect that interests me. It's everything.
Yeah.
You know, and it's all critically important to what I do.
Mhm. Do you remember any of your biology classes in college, in your undergrad at all?
Some of them I remember. The basic biology class I cannot remember much about. I remember taking a class on virology when viruses were really just being, not really discovered, but just being researched and really understood. And I remember that. But the thing that I remember most, the course I remember most, was a course in vertebrate physiology. And for the life of me, I cannot remember the professor's name, but he was probably the best professor I ever had in college.
Really?
Maybe in any course. He was very involved. He obviously personally cared. And every exam you took, he actually had handwritten it out himself. If he was questioning you about a skeletal system, he drew the bones and everything and asked you to name them.
Wow.
It was really great. But I remember that very well. That was my senior year in college. And we had a great vertebrate physiology lab that went along with it.
That's cool. Did you do any research or anything in your undergrad that had to do with, like, anything medical or biology related?
No, I didn't. I didn't do any individual research myself. I did work in as a part-time job for a chemical engineering research lab at EP Shock Lab, the chemical engineering building. I worked for some grad students. I was one of their lab assistants, but I didn't do any on my own.
Okay. What kind of research was that? Like, what were you researching?
It was in petroleum engineering. They were investigating the use of surfactant substances to help extract oil. So, which is interesting. Obviously, when you put oil and water together, you get two phases.
Mm-hmm.
They would inject. If you inject surfactant, you can actually emulsify some of the oil in the water and pump it out. And whenever they did it in the lab, they would mix them together. You would get a three-phase solution. And they were actually doing chromatography to analyze the different compositions of each layer of that. And so I was involved in setting those up and doing some of that.
That's pretty cool. Let's see. Okay, kind of going back to pulmonology, just in general. What were some of the hardest things that you faced, like, on your path, like, to become a pulmonologist, or just anything in med school or in your residency?
Well, it's just in general. It's a very long and tough path.
Yeah.
You know, it's from the time you graduate high school to the time you actually practice in your specialty is 10 years.
Okay.
Actually, it's more than that. It is 10 years after you graduate college. So you have. I think we always joked that I was in, I think, the 26th grade when I graduated. So you get out of high school, you do 4 years of college, 4 years of med school, 3 years of residency, 3 years of fellowship, and I think that adds up to 14 years.
Wow, that's a lot.
It added to 12, and 26 years.
Dang.
And it's hard work. You kind of, we always say you sacrifice your 20s to be a physician, and you almost do, because it's very hard work during that whole time. But it's worth it when you get there.
Mm-hmm.
But it's just the length of time and the difficulty of it.
Alright. Did you have any people, like, any sort of mentors or people that you looked up to when you were in, like, any of those stages to becoming a pulmonologist?
There were, and in fact, there's more than one. At each stage, you usually have a few people that you remember that had helped you, or at least that you wanted to be like. Some of the internal medicine attending physicians that really enjoyed their patient care, enjoyed interacting with us. In pulmonary, I had a great division director who was very inspiring, who was a great pulmonologist. He also was an NIH trained researcher, and was just a really good person who kind of let us do what we needed to do, but also gave us guidance. So I had several along the way. It's kind of hard for me to pick out individuals, but there's always mentors along the way that help you along.
Do you remember anybody in your undergrad, specifically any professors that you especially looked up to or that you admired?
There's a couple. The vertebrate physiology professor I mentioned, and I'm still really embarrassed at myself that I can't remember his name because he literally was probably the best teacher I ever had. There was a chemical engineering professor, I think he's still alive, named John McKenna. He was.
He's named. I think it's named after him.
Yeah, but he was one of the main professors for chemical engineering. He was just a wonderful man, a very good teacher, one who obviously cared about his students, and everybody loved him. And he also was, for a professor, very introspective. And there was one exam he gave our class, and I think we had about 40 people in the class, and it was called, it was Process and Plant Design is what it was called. But actually, no, it's called Unit Operations. But it was a very difficult course. It kind of integrated all of the basic science into designing different operational units for designing a chemical plant. Well, he gave an exam, and everybody in the class failed. Everybody.
Wow.
And he got in front of us the next day and said, well, you know, I was telling my wife the other day, you know, after I graded these, how disappointed I was in my class for having everyone fail this test. And she said, well, John, if everyone in the class failed your test, maybe you're the problem and not your class. And he was stood and said, you know, I thought about that, maybe so. That grade doesn't count. We're going to move on.
Oh, wow.
Now, he was a great man, and I remember when my daughter Laura was in UT, we went to a football game, and it was a football game. That's our crazy dogs.
Oh, they're so cute. I can't even be mad.
And they were honoring John McKenna. It happened by chance. I was there, and he was actually on the field. I think he was in his 90s.
Oh, wow. That's insane. She's like, who's that?
We have spectators over here.
Oh, you're good. They're so cute. Adorable.
He just wants to kind of interrupt things.
Okay, let's see, what have I not asked? Oh, how much time do I have? Let's see. Okay, it's been like 12 minutes.
What's that?
It's been like 12 minutes, so we don't have to go that much longer.
Okay, no, we're fine. We're
Okay.
good.
I think I'm right. Probably. Okay. What advice would you give to an undergraduate student who is pre-med or wanting to pursue anything in the medical field?
I think you should do some shadowing. I know it's required now if you want to do that, but it wasn't when I did it. But I think it's important to make sure you at least get exposure to what medicine's really like by shadowing, really either with a physician, go spend a night in the ER, do something like that, and really make sure that's what you want to do. Because it's one thing to talk about it, to read about it, to study. It's another thing to see it real. And so it's very important to do that, probably more than one time, because you're making a choice that's going to affect your life. It's a career choice. It's a difficult pathway, but it's a rewarding pathway. But you want to be sure that that's what you want to do. Because if it's not what you want to do, and you find out let's say you don't want to deal with patients, or there's certain aspects you don't like, you really shouldn't do it.
Yeah, that's definitely something. I mean, I did like the clinical rotations program at West, and it was just shadowing the whole time, pretty much. And I was like, I can't deal with patients, so I'm glad that I found that out early, because
Right, and that's important. It is not for everybody.
yeah,
And I think a lot of people go into medicine maybe from family pressure or other reasons, and not because of their own personal desire. And that doesn't work out very well. They're not going to have a happy career, and they're really not going to enjoy the training. That's where it's going to really be hard to get through that.
Yeah. Okay. Let's see. Okay, some of these questions I didn't write these, so they're really specific and weird.
Oh, that's okay.
I don't know if you would have an answer for this, like considering how long ago and probably unimportant it was. But what topics from your any of your undergrad biology courses were like kind of prominent when you were pursuing a career in the medical field?
Well, I think probably the most useful one I had was the vertebrate physiology course. Yeah, I mean that. Cause you build on several things. You go from basic science, from biochemistry, going through cell biology, and then you get into physiology, and then actually the structure of organisms. And that was really, to me, one of the funnest part. But all these steps really build on each other. Nobody likes biochemistry. I actually like organic chemistry and biochemistry, but that's the building blocks for everything. You have to understand that, and then then the next step in biology, the cell structures. How do you take these molecules and make these structures that actually are the foundations of life? And then the physiology, where the cells become an organ, which then becomes an organism. All these different steps, and all the courses play into that. So they're all important, and you just got to start at the bottom and understand each step.
Yeah.
And then you're going to forget it all.
Yeah.
but it's very important to understand the basics. Even if you forget a lot of it, you still have that basic knowledge, with you to help you understand things. And in medicine, well, we don't really now. You can't remember all the detailed molecular biology of this and that if you don't deal with it every day. You still understand the basics of it, so you can understand why a drug works and why a change in a drug works, and where this drug hits and what part of the system and why it's different than others. And that all really builds on some of the stuff you learn as an undergraduate.
Okay, kind of unrelated, I guess, but when you're like working with specific patients, how do you handle like different situations and determine like what is the best way to approach each situation? Like, what do you do? Like different testings? Do you do? I don't really know. I don't know. Kind of.
Well, if you take an example, let's say a patient comes in with a specific complaint. The very first thing you need to do is really decide what that patient has. You have to make a diagnosis. So there's several things you do to do that. The history is important. A physical exam, there's certain things that you might find that can point you one way or another. And then there's specific testing based on what your suspicion is. There's a huge battery of lab tests you can order to try to help you hone into this. There's x-ray studies you can get, x-rays, CAT scans, things like that. So there's a lot of these things that really eventually help you get to that diagnosis. So, but getting the diagnosis is the very first thing. Then you have to decide how to treat it. For many things, it's very straightforward. This diagnosis gets this treatment. Unfortunately, for probably most of the things we treat, it's not as clear cut, because this diagnosis may have these treatment options that have to be decided based on a patient's desires or what's best for them. And the other thing is that when you particularly when you deal with older patients, is that an ER visit? Okay. As you deal particularly with older patients, you don't have just one diagnosis. You have this diagnosis, and this diagnosis, and this diagnosis. And every single one may need a different treatment, and every treatment interacts with the other. So, the first step you have to do is get the diagnosis, and that does involve history, exam, testing, x-ray studies. And then you have to move on and then decide, what the best treatment is. And that requires a lot of judgment experience. It's not as straightforward as you would think. Some things actually are treated in the hospital with specific protocols. If you have this disease, for example, you come in with a heart attack, this is exactly what you do for every patient, and that works. Cardiologists come in, they put a stent in, and that's a very standard thing. For many of the things, though, it's so complicated that there's not one protocol, and you have to decide every step of it on your own. And then you have to be ready to modify that over time, depending on how the patient responds to your treatment. And so a lot of these, as we do a lot of hospital work, and so every day we see patients, we look at their labs that day and say, what's changed? Are we seeing improvement? Are we not? Do we need to change what we're doing with our treatment? So it all builds together. There's a lot of different tools you have that can help you do that.
Was there any point, like, I mean, like you said, in your undergrad, kind of deciding to go to med school was like you knew somebody who was going to go to med school, and that's just kind of how you decided. What did you want to do before that? Did you have any sort of idea of what you're going to do after your undergrad?
No.
Not really?
Well, I mean, I think it's like most, high school graduates. I'm not sure that most of them have an idea about exactly what they want to do.
Yeah.
I knew I liked science. I liked applied science engineering. I knew I liked medicine. I really wasn't quite sure what to pick, and I picked chemical engineering. But I could have also picked a chemistry degree or a pre-med from the start. I could have done any of those.
Mm-hmm.
But you have to pick one at a time when you don't really think you really know.
Yeah, exactly.
And so I did that and got into it. And that's when a few years later is when I changed and diverted back into the pre-med thing. But I just made the best judgment I could.
Yeah.
And for example, I have 4 children. 3 of them have graduated. There's one that hasn't yet. But all 3 of the initial ones did not graduate in the degree that they started.
Yeah.
They changed their mind. And that's a normal thing.
Mm-hmm. I think that's something that a lot of people, especially in biomedical engineering, are kind of figuring out that you have no idea what you want to do. Like, I'm most likely going to switch to chemical engineering.
Really?
I think so. If I get in, I apply. But we'll see. So, yeah.
But you just have to adapt. And as you learn more about things, then you can decide, do I really like this or do I like that better?
Yeah.
Although at some point you simply have to make a decision and go.
Yeah.
But in the first couple of years of college is when you really have the leeway to make changes if you decide that you want to do something different.
Yeah. And it's also very interesting to see how a lot of the people, at least a lot of the people in biomedical engineering are pre-med, and I know quite a few who have kind of realized that they're just doing it because their parents told them to do it. And it's like, I don't know, it's kind of interesting to see how, like, you're somebody who wasn't really pushed by your parents or any, like, you decided for yourself. Like, do you think that that makes a difference when people actually become doctors? Like, if it's their passion or not?
I think it does, but there's, in that group, let's say you take the group of people who are doing it, at least put into this, or kind of nudged into it by their parents without it really being their thing. Some of them turn out to really love it,
Mm-hmm.
and it really is the right thing for them. Some of them probably not,
Yeah.
I don't know. I just, I've always believed that you should let your kids decide.
Mm-hmm.
We never pushed any of our kids into any one area at all.
Mm-hmm.
Right now, out of the 3 kids that have graduated, we have one who has a master's in social work. We have one who's got a history degree and is now an officer in the Army as an Arabic linguist.
Mm-hmm.
And I have one in medical school. Very, very different things.
Yeah.
And that's what they ended up wanting to do. So you really, I think you have to let the student really decide.
Mm-hmm.
But you do have to give them guidance, because when you're applying for college, I think most kids have no really idea what even to apply, and there's so many things to choose.
Mm-hmm.
So as parents, you have to kind of help hone down their interest and really help them pick a degree field,
Mm-hmm.
but make sure that they can participate in that decision too.
So, like you said, your dad was an engineer,
He was an electrical engineer.
and is that kind of helped you pick chemical engineering?
Well, I loved engineering. He was a NASA engineer, and
Okay.
so he worked at Johnson Space Center during the days of the Apollo program. And it was a very exciting time. And so, just to be able to see what the ability of applied science, to see what engineers could do, what you could build based on science,
Mm-hmm.
that really intrigued me. And then I just love chemistry too. So it all fit together.
Yeah.
And I still think I really could have been happy as a career chemical engineer.
Mm-hmm. Would you probably have gone into industry?
Probably so.
Yeah. That's what a lot of them do, I think. And that's kind of what I want to do, which is why I want to.
'Cause you can go out there and design things and build things that actually do things,
Yeah.
And just as a tangential example, in chemical engineering. I finished a degree in chemical engineering, and our senior years when we did, I mentioned that course, process and plant design. That actually was our senior year course. It was a 1 year course, which is really brought everything together, where we had 1 year to design a chemical plant.
Okay.
And they said, you are going to make styrene monomer. You're going to design the plant to do it, and you got to analyze the economics, make sure it's profitable, and do all of this. And you know, we had all the building blocks so that we did it. So at the end of all this design thing, when we finished our project, and you actually had to design every structure of the thing, from heat exchangers to distillation columns, and have it all connected with piping. You had to have the whole design. You ended up with this with a real weird looking distillation column, looked like a mushroom. You think of distillation columns just being a tower. This one went up, out, and up like that. It's very strange looking. And it was hard to think, well, that's really what it's supposed to be. And of course, our professor again is. Well, just by happenstance, I lived in a small community of the Texas coast called LaPorte, which was in the middle of a large industrial area called Bayport. Well, it turned out that there's a company that about 4 or 5 years after I graduated built a styrene monomer plant in Bayport, 2 miles from my house.
Wow.
And the tower looked exactly like the one I designed.
That's very cool.
So it was really kind
The
of
applications are very real.
yeah, and you can actually sit down and do all this stuff on paper and design these things, and they really work. You know, and what you design on your sheet of paper is exactly what it looks like when in the industry they build it.
Yeah, that's super cool actually. Yeah, that's kind of what I've been noticing is like when we're in our intro lab for BME, we're like designing actual like things that, I mean, they're not exactly what people can use, but it's like I put this code in and it actually does something in real life. And I don't know, it's interesting because like I feel like when you're in high school you don't really do anything that's like tangible. It's all on paper and you don't really get to see like a final product. But like the stuff that we're doing in these college courses are very like real. This is kind of what it's like in the real world in these careers.
Yeah, and basic science is incredibly important. You have to have that background, that knowledge base, to be able to take that and with engineering, take that and apply it. So that's extremely important too. But I was always intrigued by taking that and making something, building something that's real, and something that did something, you know, and that step just always was, I used to always love that. And so that's really why I picked engineering, because you can do that, and you can, I think a lot of people take for granted a lot of things in our world, the technology and their phones and all that, and have no idea what led up to them being built and designed and what's underneath all that. And I just think that's really interesting.
Okay, I think we're probably out of time, so I'll probably ask maybe one more question. Yeah.
Okay.
Okay, so just as a final kind of closing question, do you have any advice in general for college students like pursuing an undergrad degree, not just like pre-med, but anything?
Try to find your passion and do what you really want to do. Unfortunately, it's not always that clear, you know, but you have to learn the things you want to do. If you have a dream, go for it. And at some point, you just have to make a decision and go down a pathway toward that. And when you do that, go all the way and go all in.
Okay. All right. Well, thank you so much for letting me interview you. Yeah, that's all I have.
Okay, very
Thank you
good.
so
You
much.
bet.
All right. Yeah, I don't want to keep you too long. I know you probably don't